Hello everybody and welcome to Statistics. Got some surprising news for you in this class. I think you're actually going to like it. Now today we are going to begin what I'm going to call the story of statistics. From the beginning of this course to the end, what you're going to find is that this class has application. It's math, but it's going to apply to the real world. It's going to apply to your research, your career. So let's get started. Now, unfortunately today we have lots of vocab words. I'm not going to read these vocab words to you. I'll leave that for you to do. I'm just going to tell you this story, how all of this applies to where we're at and where we're going. Well, the first thing in the story of statistics is we have to understand why we're even reading this story, why we're interested in this story, and it's this. We live in a culture of data. Everywhere we go, we're presented with information. Every career that every one of us is going to choose is going to involve piles and piles and piles of data. And statistics at its heart is understanding that data, sorting it out, and being able to comprehend what it's trying to tell us. Now there's two broad categories for this, for statistics. They usually fall into either descriptive or inferential. So our story of statistics is going to focus mostly on inferential as we go. That's the really interesting part. But descriptive statistics is what we'll begin with, and it has its value as well. So imagine if we've got a room full of 30 students. Now, out of those 30 students, I'm interested in knowing how tall they are. Okay, so what I do is I get the height of every student, and what I might do then is average it. I'd add them all up, divide by how many people are in the room, and I now have in my mind this image of how tall we are on average. Are we a short classroom? Are we a tall classroom? Or are we somewhere in between? Or perhaps I'd find the average test score on the last exam. In my mind, I have this picture with an average that describes us, how well we did on that test. Now, the second category, and this is where the story of statistics is going to get really interesting, is called inferential. Inferential is this. I want to know something about a big population of people. So suppose I wanted to know the average entrance exam at everyone at a massive university, like Ohio State University, for instance. Well, if I don't have every single person's record, that's going to be really difficult to do. What inferential does is it's going to work with a small group of people. And what we're going to see is that that is going to allow us to know something about the large group. This is what happens on election night. Have you ever wondered how they can decide who is going to win an election? And the votes aren't even complete yet. What they're doing is they're going to take a small group of people and infer something about the large group. Now you got to do it correctly, but when you do, this is the process of inferential. And what you're going to see is that the math is going to work and give us a good understanding about everyone in that population. So as we look at the story of inferential statistics, there are two key ideas that we're going to need the entire course. We'll talk about them quite a lot, and they're super important. It's this. I have this large group of people that I would like to know something about. So this is every student at this giant university. That's my population. That's all the people who go to this university. Well, suppose I'm interested in a mathematical number that describes this group of people. For instance, a mean. This Greek letter mu is going to be the fancy word for the average of everybody, for instance, on the entrance exam. Okay? So that's the parameter. It's a mathematical number that describes all the people. This would be an average or a mean. Or perhaps I was interested in something that was a proportion. These are the main two. So for instance, I said to everybody, hey, I want to know if you're happy at the university. The answer to that question is yes or no, and I could find the proportion of people who are happy. So these are mathematical numbers that describe all the people. Now here's the problem. If I were to get these mathematical numbers, I'd have to go to every single person at the university, which is very difficult to do. So instead, what I do is I work with a small group called a sample. I don't go to everyone at the university, just a small group of them. And what I'm going to find is the average out of that little group of people. So this is a mean as well. This is an average or a mean, but it's from my small group. And this would be an average proportion called a sample proportion. Now, these are statistics, these guys here. They're from the small group, but they're intended to describe this sample, but inferential is going to use these to try to tell us something about their big brother for everyone in that entire circle. Now, we'll talk about this a lot, so don't worry if you're not totally with me yet, but here's the idea. Population of people have a parameter, a mathematical number that describes them. But what inferential statistics does is it works with a sample and it finds a statistic, a mathematical number from that small sample. And the way inferential statistics works is the statistic from the small, S with S, sample and statistic, will describe the population parameter. So P with P. Now we'll talk more about that as we go along, but this is the key idea to inferential. So inferential statistics is going to be the heart of this course, but we need to get a really good foundation with descriptive statistics to help us on our way. To begin with, we have got to be able to have the skill of sorting our data. We need to be able to put it into the proper place so that we can use it effectively. The story I always use to introduce this topic is I live in a family of 5. I've got 3 kids. One of the least favorite jobs in the house is when it's laundry day and you've got to sort all the socks. I'll often reach into my drawer, pull out a pair of socks, and they're not mine. They're my son's or even my daughter's. These are not going to fit me. There is no use in these socks for me because they're not the right kind. So that's the idea here. Data comes into our work, comes into our job, and we have got to be able to sort it properly. Because if we don't sort it properly, it's going to have no use to us. And the most basic block for sorting data that comes into us is the idea of qualitative or quantitative. Now, I'm going to refer to qualitative as categorical, so the words don't sound so similar. They're synonyms. They mean the same thing. So categorical is essentially this. When you look at data, is it simply a word? So for instance, if I said, hey, what is your favorite color? And you tell me it's yellow, you tell me it's red or blue, that's a word. There is nothing else I can do with that except look and see, hey, count it up maybe, 5 people like yellow, 6 like blue, but it's just a word. There's nothing else to it. Or if I said, hey, where were you born? Well, you would tell me Cincinnati or Columbus or Los Angeles. It's just a word. That's it. There's nothing else to it. Well, that's categorical. Now, in contrast, the alternative is something called quantitative, when what we have been presented with is a number. We have got a real number. Suppose I say to you, how many people are in your family? You tell me 3, 5, 8. Whatever that is, that's a number. Or I said, hey, how tall are you? You say, I'm 5'9", I'm 6'3". The answer to my question is a number. Well, it's going to matter as we move forward whether we're picking correctly categorical, the words, or quantitative, the numbers. We have to sort this right. Now, really quickly, just watch out for a trick. If I were to give you a zip code, and you say, well, oh, that's a number. That obviously must be a quantitative value. Be careful. It is a number, and that's true. That's the easiest way to tell which is which. However, this number here is really just a category. This tells you about an area of the country. This is Delaware, Ohio, where I'm from, and it is nothing more than a description. So even though it's a number, it's not really a true number. And the way you tell the difference between the two, these fake numbers that are really categorical, what you do is you ask yourself, if I added them all up, could I do some mathematical work on them? For instance, an average. If I averaged all of the zip codes of everyone in our room, I would come out with something like this, 42175.623. That doesn't mean anything. There is no area of the country that would fit with this kind of average. And so this kind of average isn't real. So even though we have a number, we can see that what we're really dealing with is just a category. It describes. So categorical are words, quantitative are numbers. But watch out for the tricky ones. And the way you tell the difference is simply by asking, can I do meaningful math on these numbers? If the answer is yes, it's quantitative. If the answer is no, it's categorical. Okay, now among that way of describing data, we had categorical or quantitative, words or numbers. We have another subgroup. This is going to be an important subgroup as well. Everything we're going to talk about is going to be important in the long term in terms of our story. But we want to see if you have quantitative, if you have the kind of data coming in that are numbers, we could break this into two different categories, subcategories. One of them is discrete and the other is continuous. And so discrete data, it's a little bit hard to define mathematically, but it's this, that there is a finite number of choices. And what I mean is you could possibly count all of these up. So if I were to say, we'll talk about this more later, but the idea is this. If I said, how many siblings do you have? It would be possible to count all the choices. You've got 1, 2, 3, 4, 5. So on the other hand, continuous data is that there are an infinite number of decimal places that are possible, and we would never be able to count them. So for instance, if I said how tall you are not really 6 foot tall. You're actually 6.000130015. It would go on forever. And so that would be continuous data. We have two types, two subcategories for these numbers, these quantitative ideas. One is discrete, where it would be possible to count up all the choices, or continuous, where because of decimal places, there's just so many values, it would be impossible. So the most important way to sort the data that comes in is whether it's categorical or whether it's quantitative, words or numbers. We're going to take a second look, another look at a different system called the levels of measurement. Now, there is a connection between the two systems, but I think it's easier for students to just think of it as an entirely different system. So we sort by categorical or quantitative, or I may ask you the level of measurement. And you're going to see that there's an increasing level here. It's going to build. Now, in the slides I've provided, you're going to have formal definitions of all of these with some more detail and some examples. But I'm going to just take you through this slide, which tells you the fundamental idea of how to tell the difference. So the first is this. Nominal is the lowest level of measurement. And if I asked you what's your favorite color, the answer is a word. It's yellow, blue, green. There is nothing else you could do with that. It's just a word. I can't do anything else to organize it. That's nominal. The second, however, is called ordinal. It's still a word, but you'll see there's some kind of natural order to it. If I were to ask you how happy you are at the university that you're attending, the answer to that might be a little bit happy, really happy, extremely happy. Now, those measurements, the answers were a word. I am happy. But you see, there's a natural order that can be placed here. You're going from the least happy to the most happy. There is an order to it. So it's a word, but you can put them in a natural order. So we've stepped up from just nominal. Now we can order this information. All right, now we're going to move to numbers. So this is really quantitative now. But we're going to take a measurement, and we find we get a number. But interval does not have a real zero. What do I mean by that? If I were to take temperatures, for instance, and temperature is the most common measure of interval, example of interval, I don't have a genuine zero. So what does the temperature 0 degrees mean? It doesn't mean emptiness. It doesn't mean there's no temperature. In a real sense, it's just another temperature, because there are negative temperatures. So there's not a nothingness. So when you measure and there is not a genuine zero, you have interval. It's numerical now. We've got quantitative stuff, but it doesn't really have a zero. And our last level of measurement is ratio. With ratio, it's quantitative again. We've got numbers, but there is a genuine starting point. There is a genuine zero. So if I asked you, how many siblings do you have? There is the possibility that you don't have any at all. It's a real zero. There is no such thing as negative siblings. So we have this second system of how to measure things. Nominal, there's nothing but words. There's nothing else we can do. Ordinal, they're words, but there is some natural ranking that can be assigned to them. Interval, where they don't have a genuine zero. There is not really a zero. Zero is just another measurement. And finally, ratio. Zero actually means emptiness, and there is nothing below it. The box is empty, you have 0 siblings, and there are no negatives. Okay, our last slide for today is going to talk about where we get this data. Now, 2 of the main ways that we're going to focus on in this course of where the data comes from for statistics, where our statistical data comes from, are from an experiment or from an observational study. Now, I have more formal definitions of each of those right here. However, what we want to just see is the distinction between them. Here's how you tell the difference. If I were interested in going down to my local middle school and seeing how students do if they use a calculator on a math exam, and I do nothing but I sit there and I watch them, I see how the students score when they finish using the calculator versus the group that doesn't. I haven't in any way changed their life. All I've done is I have watched. Well, that's an observational study. I simply observed them. I did not impact their daily life. Now, however, if I had gone to the school and I'd selected 25 students to be allowed to use the calculator and a different group of 25 to take the test without the calculator, well, now I've messed with their life. I have impacted them in some meaningful way. This has become an experiment. So, the way we get data to come in, there are others, but the main focus for our course, we'll talk about observational studies, where we're simply watching people. We haven't manipulated them in any way, or experiments, where we have literally changed their circumstance in order to collect our data. And so we've begun the story of statistics, and here's what we have talked about so far. We want to understand data because it's going to have such a huge impact on our careers and our lives in every way. So the first thing we want to do is understand that there's 2 ways this course will focus on. Descriptive, which is just giving us a picture of better understanding of the numbers, and inferential. That's the story where there's a big population and we'd like to know something about them, but it's too hard to do on our own. So what we'll do is take a sample and find a statistic, S with S, P with P. That's how inferential will work, and allow the math number from the sample, the statistic, to tell us about the population parameter. Next, we saw that as data comes in, we need to organize it. We need to sort it properly in order to get its value. We saw that we have categorical, which are words, versus quantitative, which are numbers. We saw then that we could break quantitative down into two subgroups, discrete, where we could actually count up all the possibilities, or continuous, where there's an infinite number of possibilities and we can't count them all. We then saw a second system for organizing our data called the level of measurement, nominal, where it was simply words, ordinal, words that can be put into an organized system of a ranking, interval, which is some kind of number, but which doesn't have a true zero, like temperatures, and finally ratio, that has a real zero, that means emptiness. And lastly, we talked about how we collect some of this data, where we took a look at experiments versus observational studies. Observational studies, we do nothing but observe people. In experiments, we have somehow impacted their lives. And that is the foundation and the beginning of the story of statistics.